All right, so here's the actual proof of concept. I've got everything hooked up now. I definitely modified these alligator clips a little bit. They now have 4-gauge wire running straight to the jaws. The 8-gauge just wasn't going to cut it. We still are using the 8-gauge to charge, but that's only 75 amps, which 8-gauge can just barely handle. This is actually 200-degree Teflon. These alligator clips are very, very high quality. I don't remember where I got them from, but this is 200-degree rated Teflon, and so that's actually can handle up to, I believe, 90 amps with 8-gauge, which is quite impressive. So of course we're using these 75 amp Anderson connectors kind of on the high end for a continuous load. I think if I remember correctly, I think they're rated for 125 amps with a single conductor. If you put multiple in series is when you have to derate them to 75. But anyway, yeah, this is how the test is all going to be set up. So the hardware is finished, except that we're going to put it outside, and of course we're going to unwind the spool. I'll just mention that again because it's quite a bit of power we're syncing across that wire. So what we have now is the top supply is running the gate on our MOSFET, and this is basically shorting out this coil through the battery, and then this lambda gen charges. And so what the test will do in software is it will first discharge the pack, which this is now discharging, and while it's doing that, it's going to set this guy's output to 0 volts and like 3 volts here. And that way we can measure the actual pack voltage. So you can see right now with the 100 amps we have discharging through this coil, you can see that the pack voltage has dropped. If we turn this off, you'll see the pack voltage come back up to the 3.46. This pack is pretty empty right now. So anyway, once we've fully discharged here, then we'll turn this guy off. And of course, while we're discharging, because it's through this coil, we can't actually measure the current. We could route it through this power supply, set this power supply to 0 volts, and then measure the current here, or we could use some kind of external current shunt and measure it. I'm not going to do that. I'm just going to measure the charge current because we can of course do that here. So what we'll do now is the software will set us back up to 4 volts here, and then charge it 75 amps or whatever. And that way we're using the same measuring device, which is 4-wire remote sensing here. So it's measuring as close to the cell as we can. And so we'll measure the current in, we'll accumulate the current on the charge. We won't accumulate the current on the discharge just because of the test setup. Routing this 100 amps is annoying. You really have to think about what is routing where. You can't just like split a wire because 100 amps on it is, quite a bit of power. So what I'm going to do is I'm going to run this up here. I'm going to charge this cell and make sure nothing's getting too hot with this thermal imager. But it looks pretty good. This should be a good long-term tester. And you can of course run them both at the same time if you would like. That's pushing a lot of current through those cables. So you probably wouldn't want to do it. There's no real reason to do that because this would just be discharging into this coil here. But anyway, yeah, this is it's going to be a good test. It'll be pretty simple. The software obviously was just count the current every second, figure out the number of amp hours, and then discharge. So anyway, slightly unorthodox because we're not actually measuring the discharge current, but I don't actually have a 100 amp current shunt. The highest current shunt I have is 50 amps, so that would probably overheat. We could of course measure the voltage across a known distance on the wire and then figure out the current from that, but I'm not going to do that either because again we're looking for changes in behavior over time. So we'll be able to very accurately measure the charge current to figure out the number of amp hours in. We can't measure the amp hours out just with the test setup that we have, but I don't think it ultimately matters. So anyway, thanks for watching.